My name is Tim. Welcome to part one of my MIT xPro Capstone project presentation, which is a full stack web application called GoodEats. And I want to first begin by going over the front-end architecture, authentication, and app diagram. So this is an application created using the MERN stack. In its simplest terms, the M stands for MongoDB, in this case MongoDB Atlas, which is a database which stores any JSON data created on the front-end client side and is coded and rendered with the React and Next.js frameworks. And this application also uses Strapi, which we'll discuss in the next video, and that's on the back end. Also uses Express to help us handle URL routing and handling HTTP requests and responses. And in addition to that, also uses some additional frameworks such as GraphQL and Apollo. And React is our open source front-end JavaScript library that allows us to build user interfaces and components. The UI is built on data from the backend and rendered as HTML in the browser. Next.js is used in conjunction with React, primarily because of its ease of use and flexibility. And it is also a file system-based router built on the concept of pages. So when you add a file in the pages directory, it automatically becomes available as a root. So as you can see here, I have a app_js file custom built to be rendered on each page to set and manage global styles and shared components. And then we use React which is a front-end library, Bootstrap library, to create Bootstrap components and styling. App.js also imports the CSS and allows us to share a layout component across all the pages. This allows us to have a shared header across all pages as one example. I should also note here that a grid is implemented at media queries with a max width of 600 px or less. And I should also note here, as you can see when it comes to my UI design, that I primarily use a light green color, hex color 00F320. In UI design, green is associated with a positive outcome. So this color is used to denote both outline and solid buttons that can be pressed throughout the app. So basically, next I want to explain how we go about creating the register and login pages. So as you can see here, I have items broken down in our pages folder. We have app, checkout, index, login, register, and test for testing. And then our components, we have an auth component, cart section, cart, checkout form, context, dishes, layout, and restaurant list.js. And so as we go here, the next part is that when we have a user who's going to use the app, they have to have an authenticated username and password. They must have already signed up or signed in order to place an order. So usernames and passwords are secured using JSON Web Tokens, or JWTs. And these allow you to safely transfer data between two parties. So a user registering or logging in places with their credentials, username and password. When they do that, the server authenticates the request and creates a JSON Web Token that is signed and gives permission to access information. So with the token, the user can securely communicate with the app. And when the user makes calls to the application server, the JSON Web Token is passed with the request. If the application and the token have the same signature, the user is authenticated and access is granted. So additionally, the credentials of the user are saved in the cookie for future use in the browser. So now, in order to store our user object, we want to use context to keep track of not only that, but also to keep track of items added to the cart, so that they retain state as we move throughout the app. Cookies also will preserve the items on the page in the cart if the page is refreshed. So one of, the missed opportunities here is that I was not able to successfully set the user's name to display after signing in or signing up. I also did struggle to implement Firebase, eventually forgoing that and just using a simple sign in or log in with JSON Web Tokens as the primary mode of authentication. So finally, we come to the last piece of the first part of the project, which is our Stripe usage. And so basically, in order to process orders, we use Stripe. We create a Stripe account to get API keys, as our credit card information is sent to the Stripe API rather than through our backend server. And from here, the front end gets a token that is used to charge cards. The ID of this transaction is sent to our backend and also creates the Stripe charge. So the only challenge I encountered with implementing this was that I was receiving an error message stating that there was an internal server error or a 400 error not found. And I realized after some troubleshooting that this was because I forgot to update the create charge endpoint on the order controller order.js file on my back end. And once I added my secret key to this file, I was able to process the order successfully. So with that, that about wraps up section 1 of my Capstone presentation, and I look forward to seeing you in part 2.